Today we will discuss about the prism. We have studied the refraction of light through lenses, concave lens, convex lens, and also we have seen the refraction of light from a glass slab. So now what is prism and what is the difference you see about the emergent ray from a prism and a plain glass slab. So let us start. A glass prism, simply a prism. We also call it triangular prism. So what is prism? Suppose we have a glass slab. A slab is a three-dimensional picture and we make it on the two-dimensional board. So suppose this is the slab and we cut it triangular portion. Suppose we see it from the top. So we see what we do, we cut it in this way. Isosceles triangle, मतलब a triangle with three equal sides. So what happens? We find a piece like this. This is rectangular, but prism is triangular, having three sides. These sides. This side is triangular. You cut a triangle in this way from a glass slab. So we find a piece, triangular piece, which has the upper top face is triangle, the bottom this bottom is triangular, and the sides will also be triangular, naturally will triangular. So this type of structure is called glass structure, is called prism, and we make it on the board on the two-dimensional surface as this. Let this and this is a triangle. This is a bottom surface, and here we have three surfaces. And here the upper top surface is also a triangle. So these are two surfaces, vertical surfaces, and the third one is on that side, this, if you join this dotted portion. And this is the top triangular surface, this is the bottom triangular surface. Let it make this much. This is a glass prism. And now we understand the refraction of light through a glass prism. We have seen, let us recall about the refraction of light from a glass slab. This was a glass slab. And this is the incident ray. Here at this surface, this is the normal. And what happened? This is the air. The medium is air. This is the glass. So this interface at this point, this incident ray is not going in this direction. It bends towards the normal. This is the refracted ray. Again, here it is normal. And what happens here? This ray becomes incident ray, and this surface interface, the air and glass surface, it again refracted. Then this will be going away from the normal because air is the rarer surface. Here the refraction taking place from glass to air. So dense medium, denser to rarer medium. So the ray will, this ray will move away from the normal. So what we see that this original direction, this is the direction of this incident ray. So this is the direction of assumed direction. This is the ray. This is the direction of incident ray, and this is the emergent ray. So what we see that both rays are parallel. This distance is not varying. This is same. This is parallel. So in case of a glass, rectangular glass bar, the emergent ray, this is called emergent ray. Glass may घुसी entered into the glass and again emerges from the glass. So this is the emergent ray, is parallel to the incident. Now we take the case of prism. This is not the case of prism. So what happens? Let this be the prism. This is the base. This is the triangular side. We don't put a dotted line to see its structure, you know already. So what happens? This is the face, plane surface. So what the ray, incident ray, comes here. At this point, this is the normal. So what happens? This ray bend, instead of going in this direction, when it enters into the glass, this is N, this bends and reaches here. Now at this point, this is the normal. Here, what happens? This becomes incident ray into the glass and it is refracted here on this surface. It don't go in this direction, but it emerges. After refraction, this is the denser medium, this is the air, rarer medium. So from normal, it will move away from normal. So this is the emergent ray in this case. These are emergent rays. Emergent rays. So what we see, this is the direction of incident ray, this one. So this direction and this direction, these are in different directions, not parallel. Emergent ray is not parallel to the incident ray in case of a prism. This is a prism. So we see the primary difference that in case of a prism, the emergent ray is not parallel to the incident ray. Now the angle of deviation, what you see, this is the original direction and this is the final direction of the emergent ray. So you extend it back and this angle, let us use different color. This angle is the delta. The ray, the incident ray and emergent ray angle, and how much the emergent ray deviated from the direction of the incident ray, this one. The first deviation is this. This was the original direction where it refracted at this, you can say delta 1. And second, it was going in this direction. Instead of going in this direction, it comes here. So this is the angle of this one. From the normal, this is delta 2, and this is equal to this angle, delta 2. It is not so clear, so let us draw some other diagram. Taking some more angle, so it will be more clear. Here it is all right. Here, let us extend this some big diagram so it becomes more clear. Let us have this much. This is the prism. The case of prism, this will be more clear. This is the triangle. All the three surfaces will come together. The first one is the rays. This is the incident ray, and here normal to this surface is this. So this is instead of going in this direction, it deviates towards the normal. This is n normal की तरफ, and here it reaches here. Now the normal is this one. Instead of going in this direction, this is the normal at the surface. Instead of going in this direction straight, due to refraction, it bends away, it goes away from the normal. From this direction, it makes some more angle from the normal. So this is the emergent ray. So now, how much deviated? This is the original direction for this first one. First deviation is this, delta 1. Second deviation is this. This is the original direction when it was traveling in the glass and refracted. This is delta 2. So total deviation, if you will extend this, the emergent ray in this direction with the incident ray, so this is total deviation, delta. Here delta is equal to delta 1 plus delta 2. So we see in case of prism, the emergent ray is not parallel to the incident ray. Now it has become more clear when we take this sectional view. So now clear? It is very easy. Now we see that the ray on the both point of refraction, at this point, it bends towards the base. This is the baseline. This is the base. This is a triangle. So this is the base. What happens? You have to stretch it perpendicular to the board. So a prism is formed. So on this triangular surface, first surface, second surface and third surface. This we take a base, one of the surface. These are side surfaces. These are in this way extended, this extended in this way, this extended in this way. So you find a bar, triangular bar. So this is the case. Here, the refracted ray, this one, this is incident ray, this is refracted, this bends towards the base. Again, it reaches here, it is traveling in the inside the prism in the glass. Again, it is refracted ray. Yeah, this is final. This is called emergent ray. This again bends towards the base. So we see the refracted ray twice bends towards the base. In case of a prism, this is a, we have concluded that number one, what was the difference? In case of prism, in case of a prism, the emergent ray is not parallel to, this is the sign of parallel to emergent ray. The emergent ray is not parallel to incident ray. And number two, what you concluded, that we see the refracted rays. This is incident and this is refracted ray when it goes from air to glass. So this is the first refracted ray, and when this ray traveling in the glass reaches at this interface, glass and air, this again refracted and bends towards the base. So the refracted rays two refracted rays are there. Refracted rays both ब्रैकेट में लिख लो, bend towards the base of the prism. ये आपके शॉर्ट क्वेश्चन आंसर में काम देगा. This is the fact, this is the conclusion. Now, let us proceed. Some very interesting facts about the refraction of light from the prism. We have seen the rainbow effect. तो मिटा दें इसे. First, dispersion of light. Before discussing the dispersion of light, हम लोग dispersion, light का dispersion when it passes from the prism, जब ये प्रिज्म से एक white light पास करती है तो डिस्पर्स हो जाती है. तो इसको डिस्कस करने से पहले we will discuss about the constituent of white light. We know that, we have seen 7 colors, not much distinguished, but in the rainbow. So white light में 7 कलर की लाइट होती है, और when these 7 color mixed properly we get white light. Or opposite, you can say the white light has 7 components, or you can say white light is made up of 7 colors. Light of 7 colors. So according to wave theory, we see the 7 colors of light are number 1. We can remember it by saying Vibgyor, Vib, G-Y-O-R. These are 7 colors. First letters of each color has been taken. V stand for violet. 7 colors are V, violet, बैंगनी, हिंदी वाले भी आ गए, बैंगनी, बैंगनी, आई इंडिगो, नील, इंडिगो, नीला, नील, बी, इंडिगो, बी, ब्लू, स्काई ब्लू, आसमानी, आसमान, आसमानी, और जी, ग्रीन, हरा, वाई, very important, you will give some time, then you will understand. Y is yellow, पीला, and O, narangi, orange, narangi, shantara, narangi, and R, red. R stands for red, lal. Now you remember this word Vibgyor, so you can remember the 7 colors in order. एक के बाद एक, वन आफ्टर अदर. किसके पास कौन सा कलर है, किस एक्सट्रीम एंड पे कौन कौन से कलर हैं. वायलेट वन एंड पे, आर रेड दूसरे एंड पे, और बीच में ऑल द 5 कलर्स आर इन बिटवीन. तो व्हेन दीज आर द फर्स्ट लेटर्स इन इंग्लिश, यू टेक फर्स्ट लेटर्स इन हिंदी. हिंदी वाले लोग याद कर सकते हैं. तो ये हो जाएगा बै, नी, आह, आसमानी हरा, पी, ना, ला. क्या हो गया, बैनी, आह, पीना, ला. बैंगनी, नीला, आसमानी, हरा, पीला, नारंगी, लाल. बैनी, आह, पीना, ला. Like Vibgyor, this letter has been made बैनी, आह, पीना, ला. हिंदी के लिए बैंगनी, नीला, बैनी, आह, आसमानी, पी, ना, ला. बैनी, आह, पीना, ला. Vibgyor. These are 7 color lights. Now the important thing, the frequency of all these colors is same. Frequency nu of the light wave, nu frequency is called frequency of each color is same. This 7 colors have the same frequency, but the wavelength is different. Lambda is different. Lambda R is greater than lambda V. Lambda red is greater than lambda V. This is the lambda. Lambda R is greater than V. And you know the velocity of light. V is equal to nu lambda. How will you define? Velocity is defined the distance traveled by the time taken. You know the velocity is, what is velocity? Velocity, distance by time d by t. So what happens in the case of wave? This new is opposite to time period. Time period means completing one cycle. This is the wave. This starts from here. This is x coordinate. This is y coordinate. And this is a wave. This is one cycle. Again it goes on moving. So this is the one cycle from here. So time taken in this case is called time period. This T, capital T. And frequency is defined as the opposite to time period. Here, velocity v, you can write lambda by t. This is lambda. This distance. In time t में जो distance travel की गई यहाँ से यहाँ तक, from this 0 0 in x direction, this is lambda. So this is the distance and time is taken, one time period. एक cycle में जो time लेता है वो t, that is called time period. So this is t, and here 1 by t is equal to frequency. Frequency means cycle per second. माने how many rounds makes a wheel. There is a wheel. There is a fan, ceiling fan. How much round it makes in 1 second? Or what is the time period t? The time taken in completing one round. Understand? So this is the relation between frequency and time period. So here the thing that we have to catch is this one. Velocity nu into lambda, and this is the same for all the colors. Then what happens? This is constant for all 7 colors, so V is proportional to lambda. Wavelength, velocity, तो जिसकी wavelength ज़्यादा उसकी velocity ज़्यादा. तो रेड की velocity ज़्यादा, wavelength ज़्यादा. So what happens? The light, the red color light having more velocity deviates less. It moves fast. So what happens? Now let us draw a big prism surface. These are 3 surfaces. Suppose this is the board surface. This triangular prism is standing here at this. All these are the sides, 3 surfaces, triangular surfaces. So what you will get? This is the beam of white light. This is white light. Take a glass which have the high refractive index. So here this is the normal. I don't take normal, let it deviate. So what happens? This is the original direction. So what is the red color deviate less? So this, suppose this deviates, this is the, here the colors, different colors deviate at different angles. So this is the red, deviate less, then this is the V pure, VIBGYOR. From this side, this deviates less. Why? That is why the signals, danger signals are made with red color. red colors disperse या deviates या refracts less. So this one is R and this is orange, and in this way this deviates much. This is suppose violet V. This is V and this is R. In between there are 7 colors. Again, when they emerge, they again bend towards the base. So they reach here. So what we get? We put a screen here. We put a vertical screen here. So what we get, that this is the red light. The 7 colors are seen separately here. This is the red one. This is the violet one. So here I. This is the, suppose this. Let us take some more color. Here is the red. So what happens? We get a red band here, and we get a violet band here. So in between these, we get different band. All the 7 colors band are here on the screen. So in this way we see these all the colors. We can make all the 7 colors. Take this color here in between. This is red, this is orange, and this is yellow, and this is green, and again this is blue, and here and this is indigo, and this one is all the colors. We see that red color is deviated less deviated. This red color, this one is red, and this last one is violet, and this is red. The red light is less deviated after refraction. So we see a pattern on the screen, and this is called spectrum. Pattern of different colors came on different places, have achieved different places. The splitting of white light into 7 colors on passing through a transparent medium like a glass prism is called dispersion of light. White light is a mixture of 7 colors. You see, the dispersion of white light occurs because colors of white light travel at different speeds. We have discussed that different colors have the different speeds. So the color having the high speed deviates less. So red color goes a long way straight. Okay, when white light consisting of 7 colors falls on a glass prism, each color in it is refracted, means bends by a different angle, while the result that 7 colors are spread out to form a spectrum. The red color is deviated the least. This is written in the book. I have discussed with the facts. Now what happens? These colors may now if you put another, this is the base of the prism, we put another, all the rays bend, like the rays bend towards the base. Now you take the base on this side and you put a prism in this way. What will happen? The thing will reverse. They will reach here and the same level, this level here, all the rays. And they will emerge as a white light. This will again become this. This is white light. This is the recombination of dispersed light, bended lights of different color. Here we put a screen, then we will see a slit. This is the band of, this is the white patch, white light patch. This figure is just to understand that the deviated ray again converge, again refracted in reverse direction, and they recombine to form a beam of white light. How the rainbow effect takes place. What happens? The cause of rainbow is, or the very tiny water drops floating in the air. So when the atmosphere in rainy season, the situation, the condition is formed that many tiny drops, very small drops are floating in the air, and the sun shines upon these, means the white light rays fall on these tiny drops. So what happens? Let us make a big tiny drop. So it is very small in actual case. This is a, suppose this is a drop. So what happens when very far from the sun? Consider a simple white light ray. It's coming from here. This light ray incident here. What happens? This is the water, this is the air. So this water has the refractive index greater than, new water is greater than new air. So what happens? The refraction takes place and the light here, this becomes the red one, and this becomes the, here we receive violet, here we receive red. But the drop has got the property, this tiny drop, an internal reflection takes place. This also works as a mirror, the drop. So what happens? This ray, this red is reflected in this way and reaches here. and this one is reaches here. This is violet, this is red. Again, at this point refraction take place, so the red one, this is red one, this is going on, this is red portion of, and this is the violet. Here it acts as a what all the 5 colors are within this. We go V I B G Y O R. Here is red, here is violet. All the colors are here. We see, we cannot see, our eyes cannot distinguish all the 7 colors, but the dominant colors in this way. Here we see this in this way we see. So here on the this side, this is the red patch. ये red यहाँ शो होता है और here violet. And यहाँ बीच में green. So these primary colors are seen: green, yellow, not all the 7 colors. So we see in the spectrum. So thus a spectrum is formed. The cause are very tiny drops. They are water drops floating in the air. Many very densely floating in the air, in the sky. The formation of 7 colored rainbow in the sky shows that white light consists of a mixture of 7 colored lights. Okay, let us stop here and we will discuss some numerical questions, some numericals on this topic next day. So you have to practice theory first and then we will discuss the question answers on this topic in the next lecture. Okay, thank you.